So it's my great honor and pleasure to have my great friend and colleague, Dr. Tomohiro Nagashima, here with us from Educational Technology and Computer Sciences at the University of Saarland. So why do I invite Dr. Tomo here? Because Dr. Tomo Nagashima's teaching and research, I think, could be helpful to you all as you think about your capstone projects and teaching research. So a little bit about him. Dr. Tomo Nagashima, his students, he teaches undergraduate students in computer sciences, also master students in educational technology, and students in other disciplines like psychology. And then so you may wonder, how is he relevant for ECE or early childhood and family studies? But think about how like the general goal of what we do usually or mostly is to kind of support children's learning and development. In some ways, the way and the methodology that he used could still be helpful for us to learn from him. And then so he also teaches students with diverse cultural and professional backgrounds. His work focused on co-designing novel interaction strategies with teachers to help children reason with and learn from visual representations in intelligence system, support learners' self-regulated choice-making behaviors in an intelligence system, and then understand students' perception and preferences on learning with AI. So he does like quite a wide variety of projects and work, and then also design educational games to support engaging and effective learning in math. And then so that is a brief introduction of Tomo. Tomo, feel free to share your screen with us, and then feel free to also introduce yourself if you would like. And then we look forward to learning from you about your work and to help these students think about their own projects.
Well, thank you very much, Jenny, for introducing me. And then thank you everyone for joining today. I'm very happy to be virtually. I'm very excited to share some of the things that I do in Germany, and we'd love to have some discussions. And then you're welcome to ask any questions. You can also interact anytime if you want. So the title of this brief lecture or talk is Working with School Teachers in Educational Technology Research. And as Jenny introduced me, I'm currently a junior professor, which is an assistant professor on technology enhanced learning. I'm in the Department of Computer Science, but I work with students from different backgrounds in my work. So the plan for today is I plan to spend roughly 30 minutes or so, and these are like major sections of this talk. So I will first briefly talk about who am I, what I do, and then we will talk about working with school teachers. That's what I do mainly in my job, is to work with school teachers to design learning technologies with them. And I will talk about how it is challenging to work with school teachers. And then we will talk about how might we effectively work with school teachers. And I will go through some examples. There will be some also interactive part where you can try out my recent software. So hopefully it will be fun session. And I try to make it sort of very introductory so that you can understand even if you don't have any background, for example, in computer science and in educational research. So starting with the first section. So briefly about me, so I'm currently in Germany, but I was born and raised in Japan. After getting my bachelor's degree in education sciences, my first job was an instructional designer at like one of the largest universities in Japan. And my main job was to design online learning materials with university professors so that the students can learn well from interactive learning materials. And I did this job for 2 years, but I realized that I wanted to learn more about how what I design would help my students. And because the way that I did my work is I followed some of the established models of how to design instruction, but there was nothing that I could do to evaluate how it is helpful for students. So I decided to go to US, and I did my master's degree at Stanford University in this learning science field. I know that I guess I'm sure that you know what this field is. It's the interdisciplinary field where we think about and support human learning from different perspectives. And then I did a PhD in a field called human-computer interaction, which is also closely related field, but we're more from the computer science perspective and thinking about how people would interact with technology. So I did a PhD at Carnegie Mellon University in human-computer interaction. And then I started my current job in Germany. And my overarching goal as a researcher is how can we understand and support meaningful human learning through human-centered design of advanced technologies. I am at the intersection of these three fields. So as I said, as a human-computer interaction researcher, I take what is called participatory design. We will talk a little bit about this approach later. It's also sometimes referred to as co-design of learning technologies with community members. So I work closely with the stakeholders like school teachers, school children, parents to design learning technologies with them. And as a learning scientist, I also try to understand what is meaningful for human learning and understand how complex it is to understand and support human learning. So I again take this community-based research activity to work with school teachers and students and parents to understand and support human learning activities. And also as a cognitive science researcher, I am interested in the cognitive processes that happen learning. So whenever I create a software, I ask people to use it and not just to see whether they learn something or not. I also try to understand if they learn something, like how that happens, and if they don't learn something, why it didn't help them learn. So I try to gather a lot of different data to understand these processes. And all of these activities happen in the community. And in my case, this is mostly with educators and learners. So I often go visit schools and classrooms to observe how they do teaching and learning and understand what are the methods that they use and try to integrate those approaches in the software I design. So that what I design or create will not be helpful only for research, but also for the actual practice in the society. And the typical sort of research cycle in my lab is very iterative process where I start with talking with stakeholders, teachers, students to think about what we can do together with them. And we get a lot of feedback. We make these what we call prototypes. We start with some sketches, and then we'll gradually make more interactive ones. And then we try to create some interactive software like this intelligent tutoring system, which is an AI-based adaptive system, which guides you through step-by-step problem-solving activity. And then once we design something, we will either go to the actual classroom, or we invite children to the university to test whether this actually helps them. And as I said, I try to gather a lot of different data. So we use data to think about whether students learn, how students learn, and this data analysis will also help improve the software. So this cycle goes, again and again. So far in my work in Germany, I have created several different software. So this one that you're seeing here is we launched this about 2 weeks ago. It's a game environment where children can learn to solve this multiplication and division tasks. And then they're asked to choose among these 4 visual representations that you see now. Yeah. So you have to choose one of these to help you solve these problems. And you can I don't know if you can notice, but these are structured in a way that you start from like very concrete ones, the concrete ones representation, and then gradually go to a more abstract so that we can support the transition of their learning from a concrete representation to the abstract representation. Another one that we launched last week, which I will show you a talk a little bit more later, is an interactive, again, a game environment where students can learn how to solve the systems of equations. So when you have like two equations, x and y, you need to identify what the values are for x and y using these two equations. And then this game is supposed to help students understand the processes. Another one that we are creating at the moment, sorry, it's in German, but and so this game is an environment where you have to self-assess how you can, like your skills, your current knowledge, how much you can solve for certain topics. And then after you self-evaluate your skills, you have to choose whether you want to go to this easy path or difficult path. And the game will give you a point based on whether the choice you make, whether you go to the easy or difficult path, whether that will match your current skill. So for example, if you have sufficient understanding of certain topic, but and if you choose the difficult path, the system will say that's a correct assessment or choice. But even if you have sufficient understanding, you try to go with the easy path, the system will say, no, that's not really a good choice because you know the stuff already and you're still trying to go with the easy path. And the very recent one that we're currently designing is we're creating an environment where students would be encouraged to do the breathing exercise while solving difficult mathematics problems so that they can reduce their math anxiety. So we are, you can see that we are mostly focused on mathematics. And during this project, we work a lot with teachers, parents, and students from different age groups. So that was a brief overview of who am I, what I do. And now I'll go to the second section. So I heard that this today's lecture is about action research. So I guess you'll be learning a lot about how teachers would do their own research at the school environment, how to improve their own teaching and strategies. And we also, as a researcher, we also care about those activities. And as a researcher, but it's sometimes difficult to sort of effectively work with these teachers because our goals and teachers' goals might be not the same. So in general, teachers usually want to improve their own unique teaching in their own unique environment. So they teach something and then they want to improve how I do teaching, and then they will look for some resources or they will try different methods, and then they will evaluate how the new technology, new strategy would work or not. So they will ask this question: how can I improve what I do for my students? On the other hand, researchers in general, although there are different researchers with different interests, researchers want to do science of teaching and learning. And what this means is oftentimes we think about how can we understand how best to teach students, not only about this specific classroom or specific set of students in this particular school, but we hope to understand something that works across contexts so that we can say this can be a effective methodology, strategy that can be used in any classroom, for example. So although we are kind of in the same direction in terms of the improving teaching and learning, but we have slightly different goals and mindsets. So we have oftentimes different goals. And another way to look at this, which might be helpful, is an idea called path towards quadrant. So there is this idea that can be used to categorize research, not only in education research, but also in other research in general. So categorize research in different sort of quadrants. So these roles, yes or no, represent whether your research aims for fundamental understanding. about the science. And these columns represent whether your research considers the practical use in the society. So if for example, if this aim for fundamental understanding is yes, and consideration of use is no, you could say that this is a pure basic research. This is like an extreme case. But so for example, if you're like doing a physics research, you might be more focused on like fundamental understanding of how the nature works without little connection to the society. Although I think more and more researchers are required to think about how whatever you do has an impact on the society. But that's just an example. But the other side here is the pure applied research. So you don't really care about fundamental understanding, but you care about the use in the society. And oftentimes the example of Edison's work, who invented a lot of things, is used to kind of represent this pure applied research. So we want to create something for the society, but we don't really care about how it's going to advance the science. And the path towards quadrant is this one. So ideally, what we want to do is to achieve both, to understand fundamental, to aim for fundamental understanding, and also that can be useful for the society. So this is called use-inspired basic research. Try to understand, try to achieve both of these aspects. And we can use this framework to kind of try to understand, although not exactly the same, but what we are trying to do. So maybe you can say that the researchers are more interested in this basic research. I'm not very much interested in basic research, but many researchers, I would say, are more sort of interested in understanding how people learn to advance the scientific understanding of what we do. And teachers, on the other hand, for example, teachers who do action research in the classroom, they're more focused on this applied work. They want to improve their own teaching methodologies. They don't really care about, whether how this would advance general understanding of how people learn. They care about things that would work for their students. But ideally, we want to try to advance both. And that's something that I'm trying to do. And attempts have been made in the past from the researcher's side to kind of translate what we know about from the basic research to inform what we can do in the society, in the classroom, for example. For example, there are some resources that you can use online to inform your teaching. This is what is called the What Works Clearinghouse. You can see the title here, from the Institute of Education Sciences, which is part of the Department of Education in the United States. It's an independent organization that reviews scientific studies of how people learn and how to do teaching. And they write, like, for example, intervention reports. They do reviews of individual studies, and also they write these practice guides with the hope that these resources will be helpful for practitioners. And for example, if we take a look at this practice guide on preparing young children for school, you can see that there are some strategies that you can use. For example, regularly provide intentional, engaging instruction and practice focused on social emotional skills. Strengthen children's executive function skills using specific games and activities. Provide intentional instruction to build children's understanding of mathematical ideas and skills. They also use their own criteria to evaluate how strong the evidence is by reviewing the research studies, and they make recommendations. These practice guides can be very useful because they also talk about very detailed sort of example ideas that teachers can use immediately. And another, if you're interested in, like, if you're a teacher and if you're interested in reading more about the original sort of research studies, you can also look at the journals or papers that we write. This is from your professor. And oftentimes, however, if you want to access these research papers. And if you don't have access to the university, for example, you usually have to pay a certain amount of money to get access to this knowledge. There are ways to avoid this, and I know that your professor Jenny is also making sure that it's accessible to everyone. But still, many research studies written in these papers are not accessible to everyone in the society. Also, another movement that I wanted to highlight is an open educational resources movement. Open educational resources are defined as learning, teaching, and research materials in any format and a medium that reside in the public domain or are under copyright that have been released under an open license that permits no cost access, reuse, repurpose, adaptation, and a redistribution by others. So if you randomly search for some educational resources online, most likely what you find is copyrighted materials, which means that you could use it for your study, for example, but you cannot, for example, remix that content with other content, or you cannot make revisions and then redistribute as your own work. That is not permitted. But open educational resources are type of resources that encourages or that allow you to do anything with the resource. You might have seen this mark. This is a Creative Commons license mark on some resources or websites. This is a license that shows that whoever who wrote that article or website, who made that website, indicates that this is free to use for your any work. There are some conditions, but this is something that you will look for if you're interested in looking for resources that you may be able to use it for your own teaching or learning activities. As an example, I recently was involved in this AI pedagogy project, which is a collection of assignments or activity ideas that you can use to teach about AI or AI literacy. And you can sort of browse different types of assignments ideas, activity ideas, get inspired, and then use some of these for your own teaching and learning activities. But still, studies on this movement, like open education movement, has shown that teachers don't really have time to look for these resources. They don't have money or incentives to explore new ideas because they're already busy with their daily activities. So this also doesn't really work. So things that I have looked at are kind of, you can see that it's trying to inform what we know about basic research with the hope that this will be useful for practitioners. But this one-way approach doesn't necessarily work because, as I said, the practitioners don't really have time. If you think about families with kids, for example, I have 3 kids, and I don't really have time to explore all of these resources to think about what is good for my kids. So there can be other approaches that we can think about. And now going to this third section. How can we effectively work with school teachers or other stakeholders? I wanted to sort of go back a little bit to think about in education research involving teachers or classrooms. We can kind of categorize any research studies into 2 different types. One is research about action. Action in the sense is teaching and learning activities. So you can imagine that as a researcher, you do research on how teachers do certain teaching or how families interact with their kids at home. And in this case, you do observation or field work, observing how they do their activities. And here, you're more like an invisible person. You're maybe sitting at the corner of the classroom or at home and trying to observe what they do. You don't really want to sort of interact or intervene, influence anything. So this is research about action. The other type is research in action, which is more active involvement of researchers to influence teaching and learning activity. And this research in action is what I have been doing and what I think could be useful for to solve the problem that I mentioned before. And at the beginning, I showed this my research cycle. So this is pretty much this research in action work where we actually try to change or influence what teachers do in a classroom by closely working with teachers and students. So how could we do research in action effectively? So this, you can see these two images here. This is the same images. So research in action usually takes a form of what is called like co-design, participatory design, where we closely work with stakeholders like teachers to ask about their teaching strategies, how we can incorporate those teaching strategies. If you want to work with families like parents, you can also do the same. You can talk with them how they teach certain things to their kids, how their daily routine looks like, and then how we can improve that using different things, including technology. These and then in this example, for example, this is one of my previous studies, and we had this specific research question, which was how might we design interactive activities using this tape diagram. This is the tape diagram, this specific representation. And oftentimes these research in action activity has this clear research question that researchers bring in, and then the purpose is to get teachers' feedback. And then you iteratively design different prototypes and get another round of teacher feedback, and then you improve again and again. This is effective, but you can also think that from the stakeholders' viewpoint, there might not be sort of a great amount of agency that you can sort of exercise. So I was thinking, like, what if we talked with teachers with no predefined research questions? And that's what I did to create this software. So systems of equations. So you have like these two equations, and your task is to identify what is x, what is y. And then I believe that many of you know how to solve this type of equations. But teachers said that many students don't really understand like why certain strategies work in that way. So we wanted to make a game to help students understand that. So in this project, we started by talking with a high school mathematics teacher here in Germany who was interested in improving his own teaching. So his interest was really to improve his own teaching methods, but also he had an interest in helping research. He was interested in looking at research in general, and he wanted to talk with us because he was interested in our work. So we decided to discuss with them with no prompts, no research question. We didn't have any ideas of like what we can do with them, and rather we decided to talk with him and explore what instructional needs he has, and thought about how we might be able to help him. So we didn't bring in any research question. We instead asked him again and again, what are some problems that you have in your daily teaching, and what we could do to help him. So this is different from what I said before of like bringing in what we want to do, which is oftentimes the methods that researchers use, to bring in the research question that we have and ask for feedback. This project, instead, we had no research question, nothing that we prepared before. And after several discussion sessions, we decided to create interactive exercises that teach students the meanings of different strategies for solving systems of equations. Because we found out that this teacher had said that he has a trouble teaching this systems of equations. He thinks that students would understand this procedure of how to move things around to identify x and y, but he thinks that the students should know like the meanings of these different strategies. And then he said like there is no interactive software or activities that he could use that is available. So we wanted to design something for him. We did a lot of prototyping sessions, again, sorry, in German, but you can, I think, get an idea that we were trying to do like some drag and drop for like some interactive thing that might help students understand the procedure. And after several iterations, we created this software. And I want you to maybe like spend 2 or 3 minutes, because this software is available. You can kind of see what we created in the end. It will be great if, you know, everyone could access to this software. If you see German, you can change it to English in the upper right corner. And you can just explore what's out there and then try to interact for maybe a couple minutes. You can start with a tutorial, or you can directly go to an exercise to see how you can interact with the software. It might be a little tricky at the beginning, but we launched this project last week. So we are still sort of getting feedback and see if we can improve the details. If you have any feedback, I will be happy to take your feedback. But we worked with this teacher very closely again and again. We met him so many times to design every detail in a way that, you know, we can make something that he can actually use to improve his teaching. Well, this tool is available for free. So yeah, you can explore anytime. And that was also our intention, was to make it sort of freely available. So not just this particular teacher can use, but other teachers interested in can also use it. That's why also we wanted to make it both in German and in English. So yes, as you can see that this game is available for free, and it has this tutorial and several different exercises. And teachers, as a teacher or as a learner, you can sort of use it in a way that you want. We also have a version where you can sort of conduct like a study, actual research study. So if you're interested in doing a study, that's also an option. So in this project, so there was, as I said, there was this teacher's initiative or initiated question of how can I get interactive software that demonstrates how we solve systems of equations. And this is a question that we started with. And as the project moved on, we also tried to kind of find the research question that we would be interested in investigating. And we came up with the research question of how do interactive real world examples or representations that you see in this game would help students understand the problem solving procedure in a conceptual way. And so this researcher's research question came after this teacher's question, which is kind of not a traditional way. So our goal was to support teachers, to try to answer teachers' question, to support his goal, practical goal, to improve his teaching using this interactive software. But we also developed, in the middle of working with this teacher, our own research question, so that we can also, while achieving his goal, practical goal, we also try to understand some, what is called like basic research, like more like the scientific understanding of how people learn. And so this is kind of like a parallel thing in this process of thinking about research question, trying to achieve both. And I decided to call this parallel design. It can be defined as a design strategy that attempts to achieve both theoretical and practical goals with stakeholders without unnecessarily forcing either party to adjust their desires or goals to the others. Because oftentimes, either party has to kind of adjust their own desire in order to achieve, the other's goals. So we are exploring this parallel design where we try to achieve both practical and theoretical understanding or goals while working with this teacher. So our quest for this use-inspired basic research. This is a summary slide. So we reviewed that these one directional approach that we have reviewed are great, but they may not be necessarily the most effective approach in terms of, from the perspective of practitioners. And now we're exploring this, the teacher-initiated research project where researchers and practitioners can work together and help with each other to achieve both goals. There should be also other ways, and I keep exploring. But I know that in this lecture, in this course, I know that you are exploring and learning about different research methodologies. So it will be nice if you can kind of remember that there is this more like practitioner-oriented approach that you can also use and explore when you do research with schools, families, or other education learning stakeholders. And that is from me. Thank you very much for listening, and I'm happy to take any questions, or you can reach out to me later if you're interested in talking more. Thank you so much.
Thank you. Thank you, Tomo, for joining our class. Anyone have any questions or any comments that they would like to share with Tomo? Please feel free to unmute. I guess I'll start to give you all a couple minutes to think. So I think there are definitely a few things, right? Like we can learn and make connections between Tomo's talk and our course. For example, like observing and learning from the community, something he mentioned early on. I think this is really important as you think about your project and think about what the community needs, and then how you can develop materials that's useful for them. He also shared some resources like What Works Clearinghouse and open education resources that may serve as inspirations for you when you are doing your own project. And then talking with teachers to see what they need. So the tool that we played with just a little while ago, coming from his discussion and his work in collaboration with teachers. And I think it's actually really, really cool to just play around with it. And then how that project could both support basic research questions and then also practical use in the classroom.